Okay, so now that we have figured out how to answer some of these division problems with the Cuisenaire rods, what we're going to do now is we are going to dig a little bit deeper and see how we are going to, again, get our students to really understand dividing fractions. And eventually we do lead to that invert and multiply algorithm, but first we want them to understand why that algorithm is important. So there's some really good questions up here at the top of this next activity. So you'll notice the first one says, what is 6 red rods divided by 2 red rods? So if I get my 6 red rods here, and I want to know what it is when I do 6 red rods divided by 2 red rods, in other words, I'm thinking how many copies of 2 red rods are there in 6 red rods? So obviously my answer would be 3. Now, you'll notice the questions keep going. What is 6 white rods divided by 2 white rods? Well, the answer is still 3. What is 6 purple rods divided by 2 purple rods? The answer is still 3. So as long as our colors of rods are the same, we're basically just asking ourselves, what is 6 divided by 2? It doesn't really matter what color rods we used. So the idea in this activity is to start to get the students to realize that the same color rod would transfer to fractions with the same denominator. Okay, so what we mean here is, first of all, we have the original problem. So we have 1 divided by 1/2. Now, notice it says the problem written with the same type of numbers. So instead of having 1 divided by 1/2, since those aren't the same types of numbers, we want, again, to tell our students, remember when we talked about the same color. So instead of 1 divided by 1/2, I would have 2 halves divided by 1/2. So now I have the same type of numbers because now I have 2 halves divided by 1/2. So really all I'm doing is it doesn't really matter what color my rod is, or in this case it doesn't really matter what denominator my fraction is. All I am doing is the first numerator divided by the second numerator. So that would be 2 divided by 1. Then I write that in fraction form, and my simplified answer is 2. So again, remember, the final answer to that problem would be 2. Okay, let's look at the next one. What if I have 2/3 divided by 1/9? So now at this point, if the students aren't understanding why we're doing that, you can change the colors out in the rods. So if I have 2/3, remember it was 2 of our dark greens. So I'm just referencing back to the other sheet where we said a dark green was 1/3. So if I have 2/3 and I want to divide that by 1/9, remember our red was 1/9. Okay, right here. What I could do is I could replace my 2/3 in the green rods with an equivalent train of red rods. So first let's go ahead and do that. I'm going to replace my green rods, my 2/3 green rods, with 6 of these red ones. Because really what I have here is 2/3 and I have 6/9, and we know that 2/3 and 6/9 are equivalent. So I can think of my 2/3 as, instead of the 2 green rods, as 6 of these red rods. And now I want to know what that divided by 1/9 is. Well, so I'm asking myself, if I have 6/9, how many copies of 1/9 are in it? Well, there's 1, 2, 3, 4, 5, and 6. So what we mean by writing it as a problem with the same type of numbers, instead of 2/3, I'm going to write that equivalent fraction as 6/9 divided by 1. So again, it doesn't matter what my denominator is as long as those denominators are the same. So if I have 6/9 and I want to divide it by 1/9, really all I need to do is 6 divided by 1. And so then the equivalent problem in fraction form would be 6/1, so our answer would be 6. Now, what I'm going to do next, I would not recommend you do for your students, but I know a lot of us as teachers, or as students, when we were students, I should say, we probably all learned that invert and multiply algorithm. So I just want to show you that what we are doing here is actually working. So if I have 2/3 divided by 1/9, we were taught 2/3 times 9/1, which would give me 18/3, which would still give me an answer of 6. But when a student does that, they're losing the whole idea and concept of that they're trying to figure out how many copies of 1/9 are in 2/3. So if they can rewrite it as an equivalent fraction, then they can really see, okay, six of these 1/9 pieces fit into a total that is worth 6/9. So I think that helps them see that a lot better. Okay, so now here, if we're doing 1/9 divided by 1/3, this one's a little different because now we have a smaller fraction divided by a larger fraction. So we would have 1/9 divided by 3/9. So this is our 1/9 right here, and this is our 3/9. So remember, if I have 1/9 divided by 3/9, what I'm really asking myself is, how many copies of 3/9 are in 1/9? And when you present it like that, it's really going to make the student think, well, wait a minute, I can't even fit one whole copy of 3/9 into 1/9 because 3/9 is bigger than 1/9. So now we're talking about portions of a copy. So I can't fit a whole copy of 3/9 into 1/9. I can only fit 1/3. If I break this into threes, I can only fit 1/3 of a copy of 3/9 into 1/9. So my answer should be 1/3 because I'm doing first numerator divided by second, but now in fraction form, that's 1/3, which is 1/3. Now, again, for those of us that learned that invert and multiply, if you go ahead and do the algorithm here, you would get an answer of 1/3. But it really helps the student to see when you're going to get an answer that's larger than 1 and when you're going to get an answer that's smaller than 1. Because when they do the invert and multiply, they don't think about which fraction is larger. Is the dividend larger or is the divisor larger? They don't think about that. They just do the algorithm. And then if they make a mistake, they have no idea how to decide if their answer is mathematically reasonable or not. Is it bigger than 1? Should it be smaller than 1? What should it be? So I think this really helps them do that a lot better. Okay, so let's just do one more here. So let's do the 2/3 divided by 4/9. So we would want these to be the same type of numbers. So this would be 6/9 divided by 4/9. And again, you could continue showing students with the Cuisenaire rods, or you could even use the fraction circles if you're more comfortable with those. But again, we're just trying to show them how we can fit one whole copy of 4/9 into 6/9, but then only a little bit of another copy. So really all we're doing here is 6 divided by 4, which is 6/4, which the simplified answer would be 3/2. So what we're saying is we can fit 3/2 of a copy, or 3/2 copies of 4/9 into the fraction 6/9. So again, if we want to do it with the Cuisenaire rods, I just think this is really powerful. Here's our 6/9. So if I want to do 6/9 divided by 4/9, here's my 4/9. I want to know how many copies of this 4/9 will fit in 6/9. Well, I can fit one whole copy of 4/9 in there, but then I can only fit another half of a copy of 4/9. So I don't have enough red rods left to do this problem, but basically you can imagine 2 more of these reds I would need. So I can fit one whole copy of 4/9 plus half of a copy of 4/9, 1 1/2, 3/2. So you could also say that this is 1 1/2. So you could think of it as 1 1/2 copies of 4/9 are in. Okay, so again, we're almost at the 10-minute mark of this video. So I just kind of wanted to wrap it up. And I wanted you to really see the reason why we have students divide fractions using common denominators. And if you continue going through this module, you will see that eventually we do have them discover the algorithm for inverting and multiply. But then it actually means something to them. And it's not just some magical rule that they think somebody made up, and why do we make up all these rules is the question we always get. So they'll actually understand why that works. And then if worse comes to worse, if they ever forget that invert and multiply rule, like they do after summer when they come back to class, they don't remember how to divide fractions in their next math class. If they have this skill of turning it into the same type of numbers and thinking copies of, at least then we've given them a little bit more knowledge to help them throughout the rest of their classes. So like I said, I encourage you to work through the rest of this lesson just to see where it takes you, because it does eventually take you to the algorithm, but it's all about discovering and understanding the concept first.